So we are going to go through your review problems. You're going to want your graphing calculator out. So it's this document right here that says graphs and inverses of trig functions review. Does everyone have one of these still? Okay. Your test is not long because there's 3 questions that are omitted. So once you finish your test tomorrow, I'm going to roll you into the midterm review. So make sure tomorrow you bring those midterm review materials with you that I've been handing you the past week. Okay, so we're going to start on the first midterm review sheet tomorrow. So number 1, we're going to do, we are going to graph y is equal to cosecant of x in the interval, and I'm going to adjust that. I want us to do it from -360 to 360. Just make sure I am sharing my correct screen here. All right, so we're doing review sheet. Number 1, I'm going to change this, and let's go from -360 all the way to 360. So does that mean that my mode needs to be set to degrees or radians? Degrees, yes. So your calculator, you're going to make a conscious effort to hit mode and make sure you are in degrees. And again, if you're borrowing one from the back of the room, it will probably default back to radians. So check that. Okay. So I'm going to go to the calculator. Immediately hit mode and it's in degrees. And now my window. So the x min, the smallest value on the x-axis is -360. The largest all the way to the right is 360. In the scale, you may either call it 45 if you want the tick mark in the middle, or you can go 90. So either or. And then I'm going to go y min is -2, y max is 2, and I'm going to scale this by 1/2 just so that it looks nice on my paper. So we're going to go back to y equals. And I gave you a cosecant graph, which means that is the reciprocal of which trig function? Sine. Yep. So in the calculator, I'm going to type 1 divided by sine of x. And I'm going to hit graph. And I'm going to begin by taking a different color, and I'm going to draw in all of my vertical asymptotes, which are located at 0, 180, 360, plus and minus. So I'm going to start with that. You are welcome to get up and grab colored pencils if you'd like them. So we said asymptotes were at, so I have 0. And 180 and 360. So again, asymptotes for every multiple of 180 if you extended this graph. So every 180 degrees that you draw. And then I'm going to go this way. And back the other way as well. I'm going to go -180. And -360. Okay, so I'm going to switch colors and create my graph. Remember that you are going to approach the asymptotes, but not cross them. So values that I had here, I was at 90 and then 1. And you're going to sketch this. And then I was at 270 and -1. And then the other side. Now I'm going to be -90 and -1. And -270, +1. All right, does everyone feel confident with the graphing? Pretty easy, right? Good. So now moving on to number 2. Let me fix the screen. So number 2 asks you to use the graphing calculator to find values of x, if any, where cos of x minus sine of x is less than 1 in the interval from 0 to 360. So that means you have to change your calculator. So what's the x min now instead? 0. So I'm going to change the X min on my calculator to 0. Everything else you can keep the same though. So I'm going to go back over to the calculator and we're going to type this in. And if you have extra graph paper in your folder, you can take it out to do this problem if you'd like, or you can just make a sketch on your paper. It's entirely up to you. So I'm going to go window and I'm going to change that to 0. And I'm going to go y equals and I'm going to just type it in. And we're going to find intervals for where this is less than 1. So I'm going to go cos of x minus, what was it, sine of x. And I'm going to hit graph. And what I'm looking for is what intervals this is less than 1. So if I go up on my screen, would you guys say this is 1? And it goes all the way over to where I hit at, so what's this right here? 270. So where am I less than 1? In between 0 and 270. Yep, so that's going to be my answer. But I'm going to draw this picture on your paper, just in case you kind of like it to refer back to. So let's do this. And it only has one interval that works for this. It could have multiple, but this question, you just got one. So I'm going to go back over and make a sketch of this. Here was your 270. And then we had 0. And then it kind of started up like this. And then here would be like 90, here would be like 180. And it kind of looks like this went back up like this. This is just a sketch, okay? And then after that, it kind of continued up. So where is it less than 1? So here's 1. Do this. And it's less than 1 on the interval from 0 to 270. So in between 0 and 270. Okay, so just this section right here that's underneath. How's that? Pretty easy? We're just looking at your. So number 3, you may omit or not doing it. Oh yeah, of course. I'm sorry. Yep, this works too. Yep, so if you favor the inequality, absolutely. Yep, and if you do the interval, just remember it's after that point. Okay, so number 3, you can cross it off. If you did not do inverse trig functions. Same thing with number 4, you may omit it. You're not responsible for that. So 3 and 4 you can cross off. And let's go down to number 5. So number 5 asks you to state the domain and the range for cotangent of x. Well, it's most helpful to have a picture to pull this off of. So we're going to graph this first. So I want you to find somewhere where you've got the trig graph. If you need more, there's some in the back bookshelf. But we're going to create the picture on graph paper and we'll come back and put the answers on here. So we need to do a cotangent graph. So I'm immediately going to go back to my window. And I'm going to change this to -360 as it was. Okay. So -360 to 360. And then we're going to do cotangent. So I'm going to go y equals, and I'm going to go 1 divided by tan, and then close parenthesis. And then we're going to sketch this in between all those asymptotes. Okay, so here's your cotangent graph. You have asymptotes at 0, 180, 360, plus and minus. So I'm going to grab some graph paper. Let's see, I'm going to use this sheet. My graph paper is in radians, but again, you should be comfortable going back and forth between these. So negative 2 pi is negative 360, 2 pi is 360. So asymptotes are going in here first. Wherever you want to start them. And I was at 180, which is pi. And 2 pi, which is 360. And back this way. And last. Okay, change colors. So now you're going to create your cotangent graph. So pi over 2, we were at 0. And then you're going to approach the asymptote without crossing it. Arrows on the ends of these. Just make sure you have those, please. Same thing here. I'm just creating a rough sketch of this because we're looking for domain and range. Does your domain have restriction to it? Yes, that's the asymptotes. You are not crossing those over. And one more section. And then we need to flip back and we are going to state the respective domain and range. Okay, so before I flip, let's talk about it while it's up here. So the domain, is it everything or does it have restriction? It has restriction. Pi is 180. 2 pi is 360. So multiples of 180. Yep, so it's going to be all reals except for any multiple of 180. And now my range, if I look, I'm going down forever and up forever. So what do we say for range? All reals, just like tangent. So tan and cotan both have a range that's all reals. So now let's just translate that. All right, so we did the graph on graph paper in my domain. My domain, we're going to say all reals. This is, again, this is just one way that you can write this. So I'm going to say reals except x cannot be a multiple of 180 degrees or pi. Cannot be a multiple of 180 degrees, which is pi. And then again, the range, we said that that continues without restriction. So the range is all reals. Your pictures on graph paper. Does everyone feel confident with that one? Good. So up at the top, number 6, you may omit. And we're going to look at number 7. So 6 is an omission. 7 we're going to do. This is just like what you did on your quiz. So these are the different features of your trig equation. So you have 6 cos pi x minus pi over 2. Find the amplitude, the period, the frequency, and the phase shift. So the easiest one to start with is amplitude. What's the amplitude? 6. Can amplitude ever be negative? Can amplitude ever be 0? Okay, good. So this is never negative. That's what you see kind of come up the most often as an error. So never negative. Next, I need to find the period. So what is the formula for a period? Good. Period equals 2 pi over b. And if you were in degrees instead of 2 pi, you would use 360. But we are in radians, so we're good. So I'm going to go period is equal to 2 pi divided by what's b? Pi. Good. So the period is just equal to 2. And in the context of a word problem, that just might mean like 2 seconds or 2 minutes. Frequency, we just talked about it, was pi. So that's a coefficient in front of the x. And then phase shift. Formula for phase shift? Yep, negative c over the b. So for my phase shift, you just squeeze that in there. I know you don't have a ton of space. So negative c divided by b. So I am going to do negative pi over 2, which is pi over 2. And then over the b value, which was 5. Yep, thank you. And then you're going to do just a quick keep change flip on this. So I have pi over 2. And then I'm going to flip it. So times 1 over pi. And what happens with your pi's? Cancel. Bless you. So the phase shift is just going to be, yep, 1 over 2. So just a half. Okay. How do you feel with all those? So pretty good? Awesome. So your last two here. Number 8, you're going to write a simple harmonic motion equation. This is the word problems that we did. So this is either a sine or a cosine graph. Now your initial position is -3. So this is where I said we want to be familiar with what sine and cosine graphs look like. Where does a sine graph start? I'm going to use this space. If you drew a sine curve, where does it start? 0. And then what does it kind of do? Inhale and, yep. What about a cosine graph? Starts up, yep. Yep, it makes a big deep valley and comes back up. Yep, so it looks like this. So keep those images kind of in your head. And we're going to figure out what we have on here. We'll do that just to make them a little bit more precise. All right, so our initial position is going to be -3. So what are we working with here, sine or cosine? Well, we could work with cosine, and what if we did this? Start at -3, and then what would it do? How can I make it do this? I'm hearing good things. I'm hearing reciprocal and I'm hearing negative. So the negative is correct. So we need to put a negative in the front of your equation. Good. So I have an amplitude that's 3, a period that's 2, phase shift is 0. So I'm going to start this and go, I don't know, h of t equals, my amplitude goes in the front and it's 3. Yep, and however, yep, we got to get it to reflect. So he's right, you got to make it negative. Now I'm going to do cosine, and I'm going to go parentheses, and we've got something here that we need to find. So what else do we need to find? The frequency, good. So next I'm going to find the frequency. And you are given the period, so that's what you want to use to go off of. So I'm going to find period is equal to 2 pi over frequency. So I have 2 is equal to 2 pi over b, cross multiply, solve for b. So I have 2 times b is equal to 2 pi, and then divide by 2, divide by 2. So b is equal to 5. Yep, and then there you go. How's that equation? Pretty good. Okay. Cross off number 9 and please flip your sheet over. As your review sheet blank on the back. Okay, so I'm going to give you a new word problem instead. So instead, change number 9, please, to, I'm going to abbreviate too, okay? So there is a raft. I'm going to say raft is bobbing up and down. A total of I'm gonna go 6 meters. So it wraps is bobbing up and down 6 meters. I'm going to say beginning at the top of the wave. It's not long. Beginning at the top of the wave. The raft completes. One full cycle every 8 seconds. One full cycle every 8 seconds. We're going to do 2 things with this problem. So first thing I want you to tell me is the equation with a phase shift of 0. And we're going to write the equation with phase shift 0. I'll start with that part first. Phase shift 0. Okay, so let's think about your scenario. So it starts at the top of the wave. And it's going to do something like this, right? And it's going to complete one full cycle after 8 seconds. So what does that 8 translate into? The period. Good. So this is the period. And it tells you that the height that it's going to cover here is a total of 6 meters. So what's the amplitude going to be? Close? 3. Yep. So your amplitude is equal to 3, because 6 divided by 2. So we also know here that the period is equal to 8. And now we're going to just build your equation. So I'm going to say h of t is equal to, amplitude goes in the front, and then cosine. And then let's find it. So phase shift of 0, you don't have to worry about that. So we are given period. So I'm going to go period is equal to 2 pi over frequency. And you're going to substitute in. So I have 8 times b if I cross multiply equals 2 pi. Divide by 8, divide by 8. So b is equal to pi over 4. And now what is pi over 4 in radians? Yep, so just be aware of that. And now here's the last part of your question. So I would like you to now find, using your equation, what is the height? I'm abbreviating again. Don't want to make you write a ton. So what is the height after 12 seconds? So the 12 is going to go in for your t into your equation. However, your calculator is currently set to what mode? Degrees. So do a quick conversion so that you don't have to change your calculator. What is pi over 4 in degrees? What's 180 over 4? 45. So I'm going to go 3 cos of 45, because your calculator is in degrees currently, and then times 12 seconds. So you're going to type that right into your home screen of your calculator. It should look just like, I feel like I did it. So it should look just like this. And did everybody get -3? Perfect. So that's it. Final answer of -3. Yes. that is all your test covers tomorrow. Do you feel fairly confident with those? Okay. Again, once you finish your tests, I am going to ask you to start your midterm review because I want to give you as much review for your midterm as you possibly can have. And then again, remember your midterm starts on those dates over there displayed on the board. Okay. So your only homework tonight is to just make sure you are prepared for your test.